Hi, and welcome to Jerry's Engineering Corner. My name is Jerry DiBattista, and I'm the Global VP of Porex Virtek PTFE Business Group. And everyone, thank you so much for the positive feedback from my previous videos. I really do appreciate it. As I sat in my home office, I was thinking, what can I do next to show and demonstrate the incredible reflectivity of Porex Virtek PTFE? And it came to me that the small aluminum box that I did in my last video was more or less a homemade integrating sphere. An integrating sphere, for those of you who don't know, is a spherical device which is coated in a very, very highly reflective material. You can put a sample on one side to see how reflective it is. So in other words, if you pull it out, the light comes out, put it in, that surface will become reflective, and the detector, which is on the other side, can detect the difference of having no sample or a standard or whatever else you may have in there versus the incident light, which would come into one side. So in my little apparatus, as you can see, we have one port for the incoming light. We have a second port that can be used for the detector, and a third port, which of course could be the sample. So I thought, let's try to put some stainless steel, aluminum, and Porex Virtek to cover the one hole to act as a sample and see what happens. So let's go down to my basement workshop and give it a try. So here's our test setup today. I have 3 samples: a piece of stainless steel, a piece of polished aluminum, and of course the Porex Virtek Reflective PTFE. As you can see here, my sample setup has, my test setup has changed a little bit. When I first started it, the power coming from the lithium-ion battery was inconsistent, and so I was getting inconsistent reading on my light output. So luckily, most of you know that I have one son, Marcus, who's a mechanical engineer who helped me design a lot of the mechanical parts. I also have a son, Nicholas, who's an electrical engineer, who designed this little circuit for me for a constant voltage. That way, the light output is very consistent, and we can measure it very consistently. So let's try it and see what happens. So we'll record the data on this board with the aluminum, stainless steel, and Virtek PTFE with the microwatts per square centimeter we get. So we're starting off around 1,090, close to 1,100. So this is the stainless steel. So the initial reading is 1090. With the stainless steel, it goes up to 1108. Try it again. 1095, 1110. Now we'll try aluminum, starting off at around 1085, 1116, 1090, 1115. And lastly, the Porex Virtek PTFE starts off around 1088, 1145, 1085, again 1145. So what we'll do now is we'll calculate the amount of increase for each sample to get an approximate percent reflectivity. So with the Porex Virtek, the average increase was about 58.5 microwatts. The aluminum was about 25, and the stainless steel was about 16.5. So if you do the math, using 58.5 as the increase for the most reflective at 25, the Virtek is about 2.3 times the increase versus aluminum, and versus stainless steel, it's about 3.5 times the increase. So it's very clear how much of an improvement you can get with Porex Virtek. Well, that's it today for me, Jerry with the G.